My name is Luka Znidarsic. I'm coming from Slovenia. I'm already about nearly 15 years involved in electric propulsion systems development, mainly on so-called front electric sustainer, as you probably know it already. So this is, roughly, our team. So we are from Europe, Slovenia. So just to show you where is our little country, if you don't know. So basically we are located more or less in the middle of Europe, just south of Austria. We are neighbors to Italy, to Hungary, and on the south we have Croatia. So we are just about 2 millions of people, but quite a few gliding companies are coming from Slovenia, like Elix Now, Elix Navigation, Naviter, Canardia for interior deluxe by Gagola, Emrax Motors also. Now then Elan gliders were produced in Slovenia many years ago, which eventually become IMS and Albastar, Albatross Fly, Pipistrel is also from Slovenia, and then some repainting of gliders like glider service and so on. So, and all this is coming from Slovenia. So this is our most famous airfield, Lesce Bled. So it's well known. Many pilots are coming in spring to visit, to fly in our mountains. So basically, we mostly fly in mountains in direction to the west, to Austria, Italy, Switzerland. On eastern part of Slovenia, we have a flat area. We can fly to Hungary. Why I did the FES development? So I was always, from the beginning, I was a pure glider pilot. I did not really want to have an engine on competitions because it was my feeling that it's more or less not really advantage. But with some time, and when I get married and first daughter, then before my girlfriend, and then my wife, she was not so eager to pick me up on the field, so she said figure out something, and eventually I did this front electric sustainer system. So advantage is that at that time when I started, the batteries were really like very limited energy, and with the front electric, even in power flight, it's an aerodynamically clean configuration, so you need really small power for level flight. So nearly half compared to the retractable system as we also tested a few years ago when we also did our retractable system. So reliability in general, it's electric could be more reliable, and it is also. And of course, it's not always 100% of bullet proof, but there are some different failures which can happen. So, but anyway, in all around, it proved quite reliable in the previous years. So it's quite easy to operate. So because you basically have one switch to power up the system, and then one throttle button, and on this throttle button there is also a brake and so on. So, and with the FES system, we were able to make the system also quite light, and on lower power settings, it's also quiet, and it's also at the end environmentally friendly system. So this is for those who maybe don't know, we have basically this FES power switch. and the instrument in the cockpit. So basically, when you are getting low, you can already power up the system with the power switch on, and then you can start focusing on getting the thermal. And at the end, if when you figure out, okay, now I'm really too low to start searching, for thermal link, and then you simply rotate the throttle button, and immediately you get the power, and you can climb away. So this is a typical position of the instrument. It's in the middle on the left side, so that it's nicely visible. So here is also linked to Helix 9070 flight computer, so that originally, we designed the instrument as a 57 standard size, so that it fits to the smaller hole in the instrument panel, because there is always a problem with the space. But for those who don't see very close, or it's possible to have this data of the phase, like current, power, RPM, temperatures on the big screen of Helix 9070 or 9000, or basically on all range of Helix Now flight computers via phase bridge is connection through. So phase bridge is one thing. Another thing is so-called MOP, which is used for basically reliable detection of engine run. For many years, we were using just engine noise level, and which was just okay, and I think it's still accepted on most of competitions. Just for OLC flights, somehow they decided that phase gliders, they need to have MOP sensor. So even that for instance, Antares gliders is not necessary, and I think also for some other electric propulsion powered gliders, but for phase, they at some point they said, oh, you need this detection. So anyway, so most of the new gliders comes equipped with both MOP and phase bridge. So this is typical cross section of the motor. So basically, it's an outrunner motor, brushless DC, direct drive. So it's our own development. So because at that time when we started, there was no way to get such a motor basically off the shelf. So we did our own development for the motor. And initially, we put it on the Lux 17A, which was at that time my personal glider, and there was already a wall in front, and the nose basically was round, and was basically a good test bed for the phase system. So on most newer gliders, we adjusted the spinner shape according to the shape of the fuselage. So sometimes, for instance, on the Ventus or Discus, we have like more eggy shape of the spinner, but we figured out a way how that we can balance, and basically it's running very smoothly without vibrations. So we have mainly production in-house. We are, quite well equipped with CNC machines, wire EDM, all kind of equipment which is now used in production. So this is just, some of, stock of our motors here. Then we have, some laser engraving machines. On one of these photo, you can see, production of the prop holder on the 5-axis CNC machine. Then we have, just the propeller blades we produce ourselves. And so here is just before the final painting photo. So this is, for instance, production of the propeller mold for a retractable system. Then, okay, this is our workshop when we do the installation of the glider. So usually we do mostly just the prototypes, some new types we do in our workshop, and then we mostly teach workers of glider manufacturers so that eventually they do the installation by themselves. So before Corona, I mean this COVID, we made more installations in our workshop, but then it was a bit difficult to transport the fuselages and through the Austria and so on due to all these limitations. So from that time on, mostly we just send the like a kit with all the parts to the manufacturers, and eventually they perform the installation by themselves. So in meantime, we developed technical solutions and installations to basically more than 30 different types of gliders. So anyway, some of these gliders are more or less similar, but some are completely different. So these are our typical generation 2 battery packs. We started with generation 1, so then most gliders were equipped with Gen 2, and we developed Gen 3, and the current version is Gen 4. So, and the Gen 4, for instance, you can see we have 4 sizes of Gen 4, 2 sizes for double-seaters and 2 sizes for single-seaters. So the idea, our packs are always in the fuselage, so that it's easily possible to remove them from the glider and charge at the club or at home. So that was always kind of our philosophy. So that because the way how we fly, we always have trailers. I mean, especially in Europe, mostly the trailers are in the long row on the airfield, and you don't have electricity there and so on, and you don't drive the trailer home. You left it on the airfield, so basically all you need to take out for the next flight is just the batteries. You recharge them and install into the glider, and then you can go flying. So the standard 12-volt batteries are usually not necessary to recharge, because it's recharged by from the big batteries. So here is the Gen 4 battery packs, just so that you get a quick look how it's done. Before, up to generation 3, we always had pouch cells from Kokam, and eventually this company was acquired by another company, Solar Edge, a company producing solar panels, solar inverters, and they wanted to have batteries, but they just focus on the production of the cells for domestic energy storage, and they basically stopped producing high-powered cells, which we were required for our battery packs. So we were forced to change configuration, basically complete construction of our battery packs from pouch cells to cylindrical cells. And basically in single seaters we have like 20 cells in parallel, which creates one single block, and then we have 14 blocks like this, or 16 blocks per pack. In single seaters, so 20 cells. In double seaters, we have 30 cells in parallel. So here you can see on this picture in front, this gray is like, and red, this is, different blocks and so on. So, and then we put the bus bars on, and we do this bonding with the ultrasound, these little fusible links, so that in case that any of the cell would be, in a shortcut or something like this, then it could disconnect itself. So basically, this is similar technology, practically the same like Tesla cars have arrangements. So. So we also managed to get rid of this strap for carrying the battery pack. So with the Gen 4, we have 2 handles, so which is really comfortable to handle, and especially, lighter batteries for single seater was okay with the strap. But with the bigger, heavier battery packs, we figure out that these handles are more convenient. So, what is also important regarding the Gen 4 battery pack? So this is how these cells usually looks, and on the bottom you can see some cells after thermal runaway tests we did. And the big advantage from the safety point of view of our Gen 4 is that the cells which we are using have not just safety vent, which is standard on all these 18650 cells, just on the plus, on the bottom, on the top side, but we have safety vent also on the lower side. So during our thermal runaway tests for this asset certification, we figured out that this the vent, when you trigger the thermal runaway, sometimes gets blocked, and then you can have a side rupture, and this can lead to propagation to other cells. And eventually we decided to put special cells inside, which have also this safety vent on the minus, on the bottom side. And with this we get reliable, if the plus side is blocked, then it can open on the minus side. And here you can see on the lower right picture, you can see how it looks then, such cell, when this bottom valve is opened. So, and this is a really good way to prevent thermal runaway propagation to other cells, and greatly increase the safety of battery pack. So this is, like just sizes. So as I said, we have like small and M sizes for single seaters, and then large and extra large is for double seater. So most single seaters sustainers are using this small size. On single seaters where we want to have a self-launching capabilities, like heavier single seaters like LAC 17C with 18 meters, we developed this M version, which have a 16S configuration, so slightly higher voltage, but it makes quite a difference in the RPM and the load of the motor. And basically we can go to about 30 kilowatts of power, when with the 14S we are usually around 20-22 kilowatts of power. So, And then for the double seater, we have L and XL. L size we use on duodiscus, where we had some limitation from the max weight of non-lifting part, so we could not add a lot of weights because it was duodiscus was never available as M version, always just as a pure glider or turbo. So we had to take care about the additional weight. But on the other hand, for DG 1001, which was before also available as M version with combustion engine, so we had the more reserve regarding the non-lifting parts, and we built this XL battery pack, which two of them in parallel is already nearly 10 kilowatt hours of energy. So we managed to achieve with these big packs now that in double seater we achieve the same range like in single seater. So, and in single seater we have about 30% higher range, higher capacity, which is transferred into the range then compared to the Gen 2 battery packs before. So yeah, for instance, typically this is how it looks, the arrangement of the battery packs. So this is a photo from duodiscus, which is also in the hall downstairs. This Duo was it was a prototype, so we sold it in spring here to US. So there are two size of this L battery packs, which we name it is 14S configuration, 84 ampere hours. So these battery packs, so each pack is about 55 pounds. So this is the same weight like the battery pack on the Solo JS3. So one battery pack is about the same weight. So, but here we have a low voltage system. So each pack have only fully charged 58 volts. So and wired in serial. So we have 116 volts total voltage. So we have altogether on duodiscus about 8.4 kilowatt hours, which is it's suitable for about 16 miles of level flight. So which is in most cases more than enough. So in meantime, we managed to certify a few different types of gliders under EASA, because in Europe, if we don't have EASA certified, it's quite a headache. And we applied the first with LUX 17B in 2010, and basically, actually also already nearly in 2009. So basically in 2014, we get finally certification. So basically, it needs 5 years after first flight with FES installed on LUX 17A. And the main problem was that at EASA, they simply was not available, paperwork how to do it legally. Eventually, they made these special conditions for electric propulsion, which basically opened us a way how we can actually certify the system. So then on the HPH 304, so on the Shark is certified, on Discus 2C, on the Ventus 26A, Ventus 3, on Mini Luck this was the first EASA certified self launcher. Then about last year, LUX 17C as the first 18-meter self launcher was certified. Then from the DG aircraft aviation, so LS8 FES is certified, and now, I mean, the DG 1001 was the first FES certified double-seater. So then we had some, for lighter gliders like Silent to Electro, it was certified in Germany by Deutsche Aero Club. So we had one Antares FES is flying, which is on a national permit to fly as a kind of research project, by German authorities, by LBA. And then we have some gliders on national permit to fly, like this in France, Silent to Electro. Then we have some modified Diana 2 gliders. For instance, in France, Diana 2 FES is certified as a self-launcher in kind of not really ultralight, but something like this. Then in UK, Silent 2 Electro are flying. Then we have some APIS 50-meter versions. And here in US is basically the most simple way to get glider legally airborne, because you have this experimental category, and in Europe we are not so lucky, so we need to do all this certification. And so for here in USA we have some ISV 27. A few years ago we made it, then is a few Silent Electro, then you have a few Shem here, like a Ventus 26A, Ventus 3F, Discus 2C. Now this Duo Discus, we built also one JS1 FES. Then you have this kit from HP24 and so on. So this is basically a list of all the types which we did in nearly all. So some are still missing here on this list, but it covers most of the types. So altogether, about 380 gliders are flying with our system. And the thing is that here in the USA, I think there is a huge potential for these FES retrofits, especially if you have, for instance, an older glider and you need a refinish. I heard these refinishing, in Europe are expensive, but here in US it's crazy expensive. So, we could, if somebody is interested, we could arrange some of the retrofits in combination with the complete refinish of the glider. So this was done like that. A few gliders like this 27 of Francois Pin, and JS1 of Tony Smolder, and so on. And but anyway, till now we were mostly focused on installation for new gliders. So these retrofits we were not so eager to do, because we had a lot of work with the installations to new gliders, but with rising prices of the gliders by European manufacturers, so they are all reducing the number of gliders they are building. So we also provide a bit less systems for them. So we have some capabilities, basically some open for these retrofits of US gliders. So, and there is quite a lot of newer gliders which were designed already from the start to carry some additional weight of the fuselage for engine. But there is a lot of older gliders like Standard Zeros and DG100, Yantars, Astiers, or some of the metal, like Blahnik or Pilatus, or some very old gliders like Phoebus, Open Zeros. So these are not really suitable gliders. So from different point of view, or is a problem max weight of non-lifting parts, or is a problem that the canopy is going too much forward, like on DG gliders, the single seaters. Then, or simply the glider is not worth much already, and then according to my experience, usually if the installation costs is higher than the glider is worth, then most customers, potential customers, says no, this we will not do it. So, which is understandable. So, on the other hand, I mean, there is possibility to do also some race retrofits, you know, like retractable systems, maybe on some older gliders where the combustion engine failed. So, I mean, we have some experience with retractable systems. We did 4 years ago already HG29 RES, and but at that time we could not. There was no legal way in Europe how to certify it. So I mean, without support of the type certificate holder. So now this would be possible. So in the future, probably we will focus also a bit on these retractable systems, not just the front system. So anyway, if you are interested, if you have some glider and some wish to convert, you can ask, and we can see what can be done. So. So just for short overview, for instance, this was my first FES. This was a FES prototype, basically LUX 17A, which is a great glider to be converted. So it can be turbo, so we can throw out turbo system, combustion engine, and we can convert it to FES. It was done a few times already, so it can be done by us. It can go to the factory in Lithuania. So LUK 19 was done only one and is flying in Australia, but there are some used LUK 19s available, and we can easily convert it to FES because basically fuselage is the same like on the A model or on B or at C. So this is the new, new. It took us 3 years to get certification from EASA, even that, B version was certified from 2014. On the C, we just made some higher voltage on the battery packs and higher undercarriage, but was, 3 years of story to finally make it certified. So anyway, it's certified as a self-launcher, so you can self-launch also from grass, but the limit is basically without water ballast. So anyway, most of the gliders, pilots in Europe practically always fly without ballast, so only on competitions. They feel the water in the wings, and on the competitions, then it's simply you took the tow and that's it. But it's possibility so that you are independent during the week, or in some locations where the tow plane is simply not available. So another one, so this mini LUK is basically also from the same fuselage. At least shape, structurally, of course, it's everything done lighter. So also with the higher landing gear, and about 50 of these gliders were built, and it's nice to fly glider, little toy, easy to assemble with the light wings and easy for ground handling. So and it has, for 13.5 meter, it has basically performance of older generation 15-meter glider. So and it's nice to fly. So this is silent electro. So most of these were already, about 65 of them were equipped built as new. Unfortunately, the Alisport company went in the last few years to different hands and eventually bankrupt. So these gliders are not anymore in production. They are still exist quite a few of them with the combustion engine, with the single blade propeller, And these engines, I know the owners have problems to get the spare parts, basically some of them were already converted to FES. So this is still possible. And then the club versions, with the fixed landing gear, this was also done a few times. And then what we did, the moment, these APIs, 15-meter versions, 2 are flying in UK. Basically, a friend of mine, Roman Sushnik, who established this, MRAX company. So basically, he was making this kind of glider as a test bed for his retractable system and for testing his MRAX motors, which are now mostly installed on these retractable electric systems. So he used some of these APIs, but the problem was that with the retractable system and batteries on board, it was too heavy to fit in 315 category, 315 kilogram category in Europe. So it was never built just one. I think he built maybe 2. But also these gliders, APIs, some are with combustion engines, and they can be also converted to FES. And there is one APIS VR, like a world record, which we recently also converted to FES. And there are some APIS 2 available. I mean, this was basically German copy of this Slovenian glider. So, and this, we never did it, but probably could be also possible if necessary. So then this is a Slovenian AS glider. It's from the same company, basically, which was initially producing APIS gliders. And so it's also in the hall. So you can see one of these gliders. So a few of them they are still in production, but so if somebody is interested, it's possible to order such gliders. So you can ask Robert Mudd about possibilities. So this is, like for Italians, we modified Diana 2. And they modified to fly in 13.5 meter class with a great success. So they became, I think, world champions twice or 3 times. So anyway, it has a big, high landing gear, this Diana's 2, and on this one we actually even put a 1.2 meter prop. So it's even bigger prop. But for serial Diana's 2, I decided anyway to make a standard propeller size. And this is a photo of me in Reno SSA convention a few years ago. So about I think 12 of these gliders are equipped with FES now, and there are still some Diana 1 probably available. But so theoretically we could also convert, but it's also a little bit of problem with the canopy, because we need to modify the canopy frame and so on. But then when I sold my Luck 17A, I switched to the Schemhirt Ventus, and this was my Tutsi XA. So this was the first Schemhirt FES prototype. So I sold it a few years ago here to US. I think it's flying close to Las Vegas. So after a few years, so then I upgrade to Ventus 3, and basically this Ventus 2CX could be also retrofitted if somebody is interested. So also 2CXA can be retrofitted. They were initially prepared for the jet, but jet was never certified. So a few of them were converted to FES. So and regarding the Ventus free version, about 30 of them are already equipped with FES, and so there's not, I think, only 2 or 3 pure gliders exists, but now there is also possibility of E version. So it depends, what is, what the owner would like to. So this is Discus 2C FES. So a lot of about 70 of them were produced in recent years. Anyway, due to the cost of production and basically, which is about the same like for the Ventus, eventually company decided that they will stop the production, and instead of this, they will offer a retrofit possibility to use the Discus 2C and also to Discus 2B will be possible also in Europe. So in previous presentation by Garrett, he showed how he did this retrofit on Discus 2B. So basically it's the same fuselage, just wings are different. So it's no problem. So then this one is a photo of Duo Discus, which you can see downstairs. So with the Slovenian mountain. So just in the middle is Triglav, which is the highest mountain in Slovenia. So this photo is on Lesce airfield. So we owned this glider for 3 years. We did some great flights with, and but we want to move this now to the flapped glider, and maybe in future Arcus will become available with FES, and I mean retrofits are possible for US market, but in Europe first we need to do all this certification first and so on. So regarding the HPH, about 25 single-seater sharks were produced in previous years. So it has a nice big cockpit, so it's really great recreational pilots, especially if you are a bigger pilot. So as you know, this single-seater exists as an M version also in the jet, and also the FES. And now, so what about the twin shark? So we are working now on the FES version of a twin shark. So and I think it will be ready till, the plan is to have it ready till Aero next year, so until April. So this is 27. This is only one exists at the moment. So Garrett have a kit available for second one. So if somebody don't want to ship it to Europe, also Garrett can do the installation. We supporting him with all the jigs and tools and drawings. So anyway, the skills they have, so it's no problem. So theoretically, we could do also ISW 28 and 29. So, but it's always some. Fuselages are quite similar, but So this is 29 RES, which we did in 2020. So we also made our logo. FES is on the lower side and RES is on the top side. So like it's retractable. So so this was done 4 years ago already, but at that time there was no legal way in Europe how to certify it. without support of a type certificate holder. So we put this a bit on hold, but it's a nice product, and it's light. So it was even, I mean, the minimum wing loading in this seaplane Grand Prix rules, where you can be only, the minimum wing loading can be only 45 kilograms per square meter. So last year, the owner, he also flew E-Glide competition in Saint-Aubin in France, which was interesting. So, but I mean, from the competition point on E-Glide, it was not so easy for him to, because simply here we figure out, I mean, for a typical FES glider, you need 4 kilowatts of power for level flight. On this glider with the pylon, and so it was about 7 kilowatts of power required for level flight, and this is basically the difference. So yeah, we did one JS1 with a complete repainting, and it came back from Slovenia to US like a new glider. So, and it's still in good condition. So then LS8 retrofits are possible, but only for B version, which has a stronger spar in the wings. So DG Aviation, they published which serial numbers could be possible. So then one LS10 FES exists also. It was shipped to DG Aviation last year, and then they did the modification and was shipped back to US. So about 10 DG1000 one, so-called E-Neo, are flying. So it's interesting. 3 of them are flown by French military. So I mean, regarding the DG500, 505, I mean, the fuselage is quite similar, so probably could be also possible to do FES retrofits if necessary. So yeah, this is a project of Antares FES. So recently we upgraded it to our generation 4 battery packs, and we also introduced a switch, so that basically you can switch from the fuselage battery packs to wing battery packs, which were developed by company Advantech in Germany. So, and in combination with the wing and fuselage battery packs, you have more than 350 kilometers of range available. So, and it's also as a self-launcher with a 1.2 meter prop and a bit longer engine and so on. So, so some, I mean, these Antareses, some had some technical problems regarding the propulsion system, and so I mean, I also owned Antares with US registration for last 2 years, and I flew about 80 hours on this glider, which is a great glider, but yeah, from, I mean, until everything works, it's great, but then if something goes wrong, nobody knows really how to service, and I mean, and it's quite a challenge. So if somebody have a struggle, we can also convert it to FES if necessary. So
are they still in business?
Sorry?
Antares, do they still?
I think so, yeah. They are working. I mean, I think so. They have, I think, 21 meter version. They are developing some new battery packs, but I mean, as far as I know, yes. So, okay, so this is, you know, JS3 FES. which will be my glider. It's anyway. We equipped already the system and the bed. I mean the propeller and the complete FES system was running before New Year already, and also the instruments are installed and everything. So we are just waiting for the wings to be properly uh, finished and so on. And I hope that next season, that we will finally fly it. So, but it was like a long story. It was, 5 years from ordering. So, yeah, it took long, but eventually it will be done. So in the future, maybe, if the Yonkers will actually deliver, the design, produce JS4. So there will, we have technical solution how to put phase system on this fuselage, and JS4 will have the same fuselage. So we can do it too. So okay. So what I did also in the last year. So when I had Antares was great because until it worked, it worked, but it's heavy glider and so on, so it's difficult to assemble. And my local airfield is just short runway, 650 meters, and it's it's only grass. So and basically we don't have a towing machine available so often, and so I was thinking how I could do something like this, what it was done on the LAX 17C, which becomes a certified self-launcher. So and I take a look into the construction of the landing gear of the Ventus 3 FES sport version. And eventually I find out the solution how we can raise the undercarriage and to become a self-launcher. So just idea, so that maybe we should rename the FES versions, self-launching versions of FES gliders. Maybe in the future, maybe we should use it like as SIF, like a self-launcher, it just FES from the opposite, but maybe it would make even more, how to say, because now people are asking, so okay, it's a FES, but is this FES self-launcher or is sustainer? So it's always a bit confusion. So yeah, but initially the concept was really designed to be a sustainer only, but with time, we on the lighter gliders with some improvements, we came to the point that basically 18-meter glider can be a good self-launcher too. So okay, so this is just how I modified the landing gear on my Ventus. You see, basically, I made a special forks so that the front attachment of the landing gear front struts were moved lower, and then modified the lengths of the other landing gear parts, so that basically I gained 7 centimeters of the wheel goes more out. So basically for 10 centimeters more clearance, which is enough for self-launching, also according to EASA requirements. Actually, it's even 5 centimeters more than it would be minimally required. So, and yeah, when the wheel is retracted, is on the same location like it was before. So in Europe to achieve this, it's a lot of paperwork, and we had to do like FEM analyze of the structure and the loads and the structure, and so eventually this was accepted by ASA. So, but the first few, I mean, till May, basically, I was grounded because I had no paperwork. But yeah, so this is, how we did the, the new parts for the landing gear. And you see, this was first time the glider was standing, higher, the lower picture. And yeah, this is, so that you can better understand how these, new attachment points for the landing gear. So a bit lower, and this is, how the new forks are attached. So before were attached a little bit higher. So yeah, this is now my Ventus standing a bit higher, and at the same time we modify. I mean, I put these bigger battery packs like in LUX 17C with the 16S configuration Gen 4. So each battery is about 18 kilos, so altogether 38 kilos of batteries. I hope this tell you something, but I don't know the numbers in the pounds. So and yeah, some other modifications. And so basically I already self-launched with the inner wings full of ballast, I mean with the water, but I think maybe during the winter I will manage to tweak the system even further, so that even self-launching with 600 kilos will be possible in the future. So and yeah, maybe at some point we will certify this, but so far it's just testing and so on. So what I want to show you, maybe some of you already, for some time we have a new website, Front Electric Sustainer, and we also finally made this online shop, so which you can see under this link shop. So in this shop you can find all kind of some chargers, different chargers for the FES systems, then dischargers. Some older gliders were supplied with the older so-called discharging assistant. Now, I mean, we have available for some time this so-called discharger 2, which is a standalone device, so that you can discharge your battery packs quite quickly if you don't fly for for the next few weeks or something. So so this is available. We have some spare parts, like these data cables for charging are sometimes get damaged, and owners asking about, and we have phase bridge, and all these little things. So what we have also in the shop is this so-called LZ fuselage tool, which is used for easy pulling and pushing the fuselage into the trailer. So it's mostly useful for for instance on the Ventus M, when you have a steerable rudder, and I mean when the fuselage is heavier, or for instance on Arcus M. I mean, if you are alone, I mean it's quite difficult at the end of the day to push the fuselage inside. So I mean, I had a similar device for Antares, and then I saw that we can make something similar also for a Ventus, and at the end we made a standard version which is adjustable. The difference between the front and rear pins is adjustable. So basically we have a version now which fit to all Schemhead gliders, and also to HPH, not Twin Shark, single seat Shark, and so on. So so this is what I want to show you also. as you are here, and probably some of you owns the FES glider. So in January there was some technical note for Schemhirn gliders regarding these brass bolts on the shunt. So there was no AD about, so no airworthiness directive by EASA issued. They just issue like a safety information bulletin, and so that basically it's good to check these brass bolts. But so what happened on this picture in the middle, you can see, first happened actually on my glider, so that I had a nice wave flights on high altitude, minus 30 degrees Celsius, and then on the ground was a bit warmer and so on. And then I put the glider to the workshop, and then simply in front of me the head of the bolt fall from the shunt. So at that time I changed this, and I mean, it was very weird because before we never had, with 300 FES gliders, this was never a problem. But at some point we got these shunts with the shorter bolts, and it seems that these shorter bolts are really, not proper material, and they are from time to time. They fail, especially if maybe when they were tightening, they were used too high moment, even that we had defined the moment and so on. So anyway, this was just for the Schemhirn gliders, but I think we should change. I would suggest to change these bolts on all existing FES gliders. So because even that for 10 years there was no problem, it's better to change. It's very little amount of work, but it can increase the safety a lot. So you see, this is how the bolt. So basically what we are putting now as a replacement is a stainless steel bolt, and with the Schnorr spacer below. So just make sure that this Schnorr spacer is oriented properly. So when you are assembling, and so this is how it's on the lower left picture visible. So just to explain you why I decided that this should be changed on all the gliders. So because just recently I went to check Tony Smodler JS1 in Houston, and the problem was really that one of these bolts was broken. So I changed it with the new one, but then when I wanted to change the lower one, so I just touch it and it stays in my hand. So it really needs to be changed on all gliders. So this is how it's usually positioned on the lug gliders, this shunt. So this is how it's already replaced. And another thing, when you will be checking this on one glider, I saw this from the MOP sensor, hull sensor. I saw that these little bolts on the hinge, one part was missing. So please check if this is if both parts of the hinge are there, and you can put. You can try if it's holding well. If you can unscrew, there should be a Loctite. So I told the Helix guys that they should put a Loctite there. And it seems that recently they start putting it, but when you are checking these bolts, basically it's good to check about